Data, data, data. I can't make bricks without clay. Any guesses who said this? I'll give you a hint. It wasn't a famous tech CEO or a data analyst. The person who said this lived long before tech companies even existed. But I bet you've still heard of him. This line was said by Sherlock Holmes, the famous detective created by Sir Arthur Conan Doyle. What Doyle meant was that Holmes couldn't draw any conclusions, which would be the bricks he mentioned, without data, or the clay. You're probably not here to become a world-famous detective, but data is still the building block that you'll use for everything you do in your new data analyst career. Sherlock Holmes would agree. By starting this program, you've shown that you and Sherlock Holmes have something in common. You both have an interest in learning more. That's one of the most important qualities that data analysts can have. Now, there are a bunch of different ways to explore data, but one of the great things about data analytics is that you can often learn how you want, when you want. That might mean doing your own research, talking with people in the industry, or taking online courses. With that said, welcome to your first course. This is your introduction to the wonderful world of data analytics. Since data analytics is the science of data, you'll use this course to begin to learn all about data. Data is basically a collection of facts or information, and through analysis, you'll learn how to use the data to draw conclusions and make predictions and decisions. Personally, I didn't jump right into the data analytics field. I thought data analysis was for computer engineers. Instead, I started off with dreams of working in finance. Once I got through an internship, though, I realized it wasn't the career path I wanted to take. I started to learn about financial planning and analysis and all of the work finance analysts were doing with data. I realized that finance analysts are really just data analysts working in a finance department. These analysts were helping to guide business decisions by knowing how to use data. It was then I realized how powerful data is, and I started to embrace it. Soon enough, I realized I could do this data analysis myself. Data analytics is a big open world of opportunity. There are so many areas your analysis skills can be applied, and in all kinds of different ways. If you're new to this world, you'll learn how to identify which path and industry might suit your skills and your interests the best. And for those of you who already have some experience, we'll help you open doors to new and exciting opportunities. One of the skills you'll gain from the program is how to follow the best practices that analysts use to help make data-driven decisions. Computers are one part of the process, but analysts rely on so much more to make decisions. That's why learning how to think analytically and using your other skills and traits on the job will make your work easier. I know you already know how to make good decisions. You chose to be here after all. In this first course, you'll learn more about each phase of the data analysis process. Ask, prepare, process, analyze, share, and act. As a data analyst, you'll go through these steps as you use data to inform your decisions. Eventually, you'll see how this program itself is, in a way, its own version of this process. While I know you'll enjoy watching these videos, your trip through the first course will include a whole lot more. Other videos will take the form of vignettes where you'll learn from data analytics professionals who are already established in their careers. They'll offer words of wisdom as well as tales of their own experiences, starting off on their career path. You'll start your own data journal that will help you keep track of what you've learned throughout the course. You'll also add your own thoughts about what you're learning as well throughout the program. You'll read up on how to navigate this program in the world of data analytics. You'll complete activities, including some that will help you get in the mindset of a data analyst. Along the way, you'll also have the chance to connect with your fellow learners. Discussion prompts will give you a chance to share your thoughts and at the same time, see what your peers think about all that you're learning. These prompts will help you build a community support system to use throughout the program. All right, enough talking. Let's get started on this exciting path. Your next step awaits. Hello again. You've already learned about being a data analyst and how this program will help prepare you for your future career. Now, it's time to explore the data ecosystem, find out where data analytics fits into that system, and go over some common misconceptions you might run into in the field of data analytics. To put it simply, an ecosystem is a group of elements that interact with one another. Ecosystems can be large, like the jungle in a tropical rainforest or the Australian outback, or tiny, like tadpoles in a puddle or bacteria on your skin. And just like the kangaroos and koala bears in the Australian outback, data lives inside its own ecosystem too. Data ecosystems are made up of various elements that interact with one another in order to produce, manage, store, organize, analyze, and share data. These elements include hardware and software tools and the people who use them, people like you. Data can also be found in something called the cloud. The cloud is a place to keep data online rather than on a computer hard drive. So instead of storing data somewhere inside your organization's network, that data is accessed over the internet. So the cloud is just a term we use to describe the virtual location. The cloud plays a big part in the data ecosystem. And as a data analyst, it's your job to harness the power of that data ecosystem. Find the right information and provide the team with analysis that helps them make smart decisions. For example, you could tap into your retail store's database, which is an ecosystem filled with customer names, addresses, previous purchase, and customer reviews. As a data analyst, you could use this information to predict what these customers will buy in the future and make sure the store has the products in stock when they're needed. As another example, let's think about a data ecosystem used by a human resources department. This ecosystem would include information like postings from job websites, stats on the current labor market, employment rates, and social media data on prospective employees. A data analyst could use this information to help their team recruit new workers and improve employee engagement and retention rates. But data ecosystems aren't just for stores and offices, they work on farms too. Agricultural companies regularly use data ecosystems that include information, including geological patterns and weather movements. Data analysts can use this data to help farmers predict crop yields. Some data analysts are even using data ecosystems to save real environmental ecosystems. At the Scripps Institution of Oceanography, coral reefs all over the world are monitored digitally so they can see how organisms change over time, track their growth, and measure any increases or declines in individual colonies. The possibilities are endless. Okay, now let's talk about some common misconceptions you might come across. First is the difference between data scientists and data analysts. It's easy to confuse the two, but what they do is actually very different. Data science is defined as creating new ways of modeling and understanding the unknown by using raw data. Here's a good way to think about it. Data scientists create new questions using data, while analysts find answers to existing questions by creating insights from data sources. There are also many words and phrases you'll hear throughout this course that are easy to get mixed up. For example, data analysis and data analytics sound the same, but they're actually very different things. Let's start with analysis. You've already learned that data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. Data analytics, in the simplest terms, is the science of data. It's a very broad concept that encompasses everything from the job of managing and using data to the tools and methods that data workers use each and every day. So when you think about data, data analysis, and the data ecosystem, it's important to understand that all of these things fit under the data analytics umbrella. All right, now that you know a little more about the data ecosystem and the differences between data analysis and data analytics, you're ready to explore how data is used to make effective decisions. You'll get to see data-driven decision-making in action. So far, you've discovered that there are many different ways data can be used. In our everyday lives, we use data when we wear a fitness tracker or read product reviews to make a purchase decision. And in business, We use data to learn more about our customers, improve processes, and help employees do their jobs more effectively. But this is just the tip of the iceberg. One of the most powerful ways you can put data to work is with data-driven decision-making. Data-driven decision-making is defined as using facts to guide business strategy. Organizations in many different industries are empowered to make better data-driven decisions by data analysts all the time. The first step in data-driven decision-making is figuring out the business need. Usually, this is a problem that needs to be solved. For example, a problem could be a new company needing to establish better brand recognition so it can compete with bigger, more well-known competitors. Or maybe an organization wants to improve a product and needs to figure out how to source parts from a more sustainable or ethically responsible supplier. Or it could be a business trying to solve the problem of unhappy employees, low levels of engagement, satisfaction, and retention. Whatever the problem is, once it's defined, a data analyst finds data, analyzes it, and uses it to uncover trends, patterns, and relationships. Sometimes the data-driven strategy will build on what's worked in the past. Other times, it can guide a business to branch out in a whole new direction. Let's look at a real-world example. Think about a music or movie streaming service. How do these companies know what people want to watch or listen to, and how do they provide it? Well, using data-driven decision-making, they gather information about what their customers are currently listening to, analyze it, then use the insights they've gained to make suggestions for things people will most likely enjoy in the future. This keeps customers happy and coming back for more, which in turn means more revenue for the company. Another example of data-driven decision-making can be seen in the rise of e-commerce. It wasn't long ago that most purchases were made in a physical store, but the data showed people's preferences were changing. So a lot of companies created entirely new business models that removed the physical store and let people shop right from their computers or mobile phones, with products delivered right to their doorstep. In fact, data-driven decision-making can be so powerful, it can make entire business methods obsolete. For example, data help companies completely move away from corded phones and replace them with mobile phones. By ensuring that data is built into every business strategy, data analysts play a critical role in their company's success. But it's important to note that no matter how valuable data-driven decision-making is, data alone will never be as powerful as data combined with human experience, observation, and sometimes even intuition. To get the most out of data-driven decision-making, it's important to include insights from people who are familiar with the business problem. These people are called subject matter experts, and they have the ability to look at the results of data analysis and identify any inconsistencies, make sense of gray areas, and eventually validate choices being made. Organizations that work this way put data at the heart of every business strategy, but also benefit from the insights of their people. It's a win-win. As a data analyst, you play a key role in empowering these organizations to make data-driven decisions, which is why it's so important for you to understand how data plays a part in the decision-making process. Now that you know the 5 essential skills of a data analyst, you're ready to learn more about what it means to think analytically. People don't often think about thinking. Thinking is second nature to us. It just happens automatically. But there are actually many different ways to think. Some people think creatively, some think critically, and some people think in abstract ways. Let's talk about analytical thinking. Analytical thinking involves identifying and defining a problem and then solving it by using data in an organized, step-by-step manner. So as data analysts, how do we think analytically? Well, to answer that question, we will now talk about a second set of 5, the 5 key aspects to analytical thinking. They are visualization, strategy, problem orientation, correlation, and finally, big picture and detail-oriented thinking. Let's start with visualization. In data analytics, visualization is the graphical representation of information. Some examples include graphs, maps, or other design elements. Visualization is important because visuals can help data analysts understand and explain information more effectively. Think about it like this. If you are trying to explain the Grand Canyon to someone, using words would be much more challenging than showing them a picture. A visualization of the Grand Canyon would help you make your point much quicker. Now let's talk about the second part of analytical thinking, being strategic. With so much data available, having a strategic mindset is key to staying focused and on track. Strategizing helps data analysts see what they want to achieve with the data and how they can get there. Strategy also helps improve the quality and usefulness of the data we collect. By strategizing, we know all our data is valuable and can help us accomplish our goals. Next up on the analytical thinking checklist, being problem-oriented. Data analysts use a problem-oriented approach in order to identify, describe, and solve problems. It's all about keeping the problem top of mind throughout the entire project. For example, say a data analyst is told about the problem of a warehouse constantly running out of supplies. They would move forward with different strategies and processes, but the number one goal would always be solving the problem of keeping inventory on the shelves. Data analysts also ask a lot of questions. This helps improve communication and saves time while working on a solution. An example of that would be surveying customers about their experiences, using a product and building insights from those questions to improve that product. This leads us to the fourth quality of analytical thinking, being able to identify a correlation between two or more pieces of data. A correlation is like a relationship. You can find all kinds of correlations in data. Maybe it's the relationship between the length of your hair and the amount of shampoo you need. Or maybe you notice a correlation between a rainier season leading to a high number of umbrellas being sold. But as you start identifying correlations in data, there's one thing you always want to keep in mind. Correlation does not equal causation. In other words, just because two pieces of data are both trending in the same direction, that doesn't necessarily mean they are all related. We'll learn more about that later. And now, the final piece of the analytical thinking puzzle, big picture thinking. This means being able to see the big picture as well as the details. A jigsaw puzzle is a great way to think about this. Big picture thinking is like looking at a complete puzzle. You can enjoy the whole picture without getting stuck on every tiny piece that went into making it. If you only focus on individual pieces, you wouldn't be able to see past that, which is why big picture thinking is so important. It helps you zoom out and see possibilities and opportunities. This leads to exciting new ideas or innovations. On the flip side, detail-oriented thinking is all about figuring out all of the aspects that will help you execute a plan. In other words, the pieces that make up your puzzle. There are all kinds of problems in the business world that can benefit from employees who have both a big picture and a detail-oriented way of thinking. Most of us are naturally better at one or the other, but you can always develop the skills to fit both pieces together. And now that you know the 5 aspects of analytical thinking, visualization, strategy, problem orientation, correlation, and big picture and detail-oriented thinking, you can put them to work for you when you're working with data. And as you continue through this course, you'll learn how. Let's recap what we've learned about analytical thinking so far. The 5 key aspects are visualization, strategy, problem orientation, correlation, and using big picture and detail-oriented thinking. And we've seen how you already use them in your everyday life. We also talked about how different people naturally use certain types of thinking, but that you can absolutely grow and develop the skills that might not come as easily to you. This means you can become a versatile thinker, which is a very important part of data analysis. You might naturally be an analytical thinker, but you can learn to think creatively and critically, and be great at all 3. The more ways you can think, the easier it is to think outside the box and come up with fresh ideas. But why is it important to think in different ways? Well, because in data analysis, solutions are almost never right in front of you. You need to think critically to find out the right questions to ask, but you also need to think creatively to get new and unexpected answers. Let's talk about some of the questions data analysts ask when they're on the hunt for a solution. Here's one that will come up a lot. What is the root cause of a problem? A root cause is the reason why a problem occurs. If we can identify and get rid of a root cause, we can prevent that problem from happening again. A simple way to wrap your head around root causes is with a process called the 5 whys. In the 5 whys, you ask why 5 times to reveal the root cause. The 5th and final answer should give you some useful and sometimes surprising insights. Here's an example of the 5 whys in action. Let's say you wanted to make a blueberry pie but couldn't find any blueberries. You'd be trying to solve a problem by asking, why can't I make a blueberry pie? The answer would be, there were no blueberries at the store. There's why number 1. So you then ask, why were there no blueberries at the store? And discover that the blueberry bushes don't have enough fruit this season. That's why number 2. Next you'd ask, why was there not enough fruit? This would lead to the fact that birds were eating all the berries. Why number 3, asked and answered. Now we get to why number 4. Ask why a 4th time, and the answer would be that although the birds normally prefer mulberries and don't eat blueberries, the mulberry bushes didn't produce fruit this season. So the birds are eating blueberries instead. And finally, we get to why number 5, which should reveal the root cause. A late frost damaged the mulberry bushes, so they didn't produce any fruit. So you can't make a blueberry pie because of a late frost months ago. See how the 5 whys can reveal some very surprising root causes? This is a great trick to know, and it can be a very helpful process in data analysis. Another question commonly asked by data analysts is, where are the gaps in our process? For this, many people will use something called gap analysis. Gap analysis lets you examine and evaluate how a process works currently in order to get where you want to be in the future. Businesses conduct gap analysis to do all kinds of things, such as improve a product or become more efficient. The general approach to gap analysis is understanding where you are now compared to where you want to be. Then, you can identify the gaps that exist between a current and future state and determine how to bridge them. A third question that data analysts ask a lot is, what did we not consider before? This is a great way to think about what information or procedure might be missing from a process, so you can identify ways to make better decisions and strategies moving forward. These are just a few examples of the kinds of questions data analysts use at their jobs every day. As you begin your career, I'm sure you'll think of a whole lot more. The way data analysts think and ask questions plays a big part in how businesses make decisions. That's why analytical thinking and understanding how to ask the right questions can have such a huge impact on the overall success of a business. Later, we'll talk more about how data-driven decisions can lead to successful outcomes. In an earlier video, you learned about 5 essential analytical skills. As a reminder, they are curiosity, understanding context, having a technical mindset, data design, and data strategy. In the next couple of videos, we'll explore how these abilities all become part of data-driven decision-making. But first, let's look at the concept of data-driven decision-making and why it's more likely to lead to successful outcomes. You might remember that data-driven decision-making involves using facts to guide business strategy. Data analysts can tap into the power of data to do all kinds of amazing things. With data, they can gain valuable insights, verify their theories or assumptions, better understand opportunities and challenges, support an objective, help make a plan, and much more. In business, data-driven decision-making can improve the results in a lot of different ways. For example, say a dairy farmer wants to start making and selling ice cream. They could guess what flavors customers would like, but there's a better way to get the information. The farmer could survey people and ask them what flavors they prefer. This gives the farmer the data they need to pick ice cream flavors people will enjoy. Here's another example. Let's say the president of an organization is curious about what perks employees value most. She asked the human resources director, who says people value casual dress code. It's a gut feeling, but the HR director backs it up with the fact that he sees a lot of people wearing jeans and t-shirts. But what if this company were to use a more structured employee feedback process, such as a survey? It might reveal that employees actually enjoy free public transportation cards the most. The human resources director just didn't realize that because he drives to work. These are just some of the benefits of data-driven decision making. It gives you greater confidence about your choice and your abilities to address business challenges. It helps you become more proactive when an opportunity presents itself, and it saves you time and effort when working towards a goal. Now let's learn more about how these 5 skills help you tap into all the potential of data-driven decision making. First, think about curiosity and context. The more you learn about the power of data, the more curious you're likely to become. You'll start to see patterns in relationships in everyday life, whether you're reading the news, watching a movie, or going to an appointment across town. The analysts take their thinking a step further by using context to make predictions, research answers, and eventually draw conclusions about what they've discovered. This natural process is a great first step in becoming more data-driven. Having a technical mindset comes next. Everyone has instincts, or, as in the case of our human resources director example, gut feelings. Data analysts are no different. They have gut feelings too, but they've trained themselves to build on those feelings and use a more technical approach to explore them. They do this by always seeking out the facts, putting them to work through analysis, and using the insights they gain to make informed decisions. Next, we come to data design, which has a strong connection to data-driven decision making. To put it simply, designing your data so that it's organized in a logical way makes it easy for data analysts to access, understand, and make the most of available information. And it's important to keep in mind that data design doesn't just apply to databases. This kind of thinking can work with all sorts of real-life situations too. The basic idea is this: if you make decisions that are informed by data, you are more likely to make more informed and effective decisions. The final ability is data strategy, which incorporates the people, processes, and tools used to solve a problem. This is a big one to remember because data strategy gives you a high-level view of the path you'll need to take to achieve your goals. Also, data-driven decision-making isn't a one-person job. It's much more likely to be successful if everyone is on board and on the same page. So it's important to make sure specific procedures are in place and that your technology being used is aligned with your data-driven strategy. Now you know how these 5 essential analytical skills work towards making better data-driven decisions. So far, many of the examples you've heard are hypothetical. That means they could be true in theory, but aren't specific real-world cases. Next, we'll look at some real examples. I can't wait to share how data analysts put data to work for amazing results. In this video, I'm going to share some case studies that highlight the incredible work data analysts do. Each of these scenarios shows off the power of data-driven decision-making in unexpected ways. The first story is about Google. As I mentioned a little while back, here at Google, our mission is to organize the world's information and make it universally accessible and useful. All of our products, from idea to development to launch, are built on data and data-driven decision-making. There are tons of examples here at Google of people using facts to create business strategy. But one of the most famous ones has to do with Google's human resources. So here's how it went. The HR department wanted to know if there was value in having managers. Were their contributions worthwhile, or should everyone just be an individual contributor? To answer that question, Google's People Analytics team looked at past performance reviews and employee surveys. The data they found was plotted on a graph because, as you've learned, visuals are extremely helpful when trying to understand a problem or concept. The graph revealed that Googlers had positive feelings about their managers, but the data was pretty general, and the team wanted to learn more. So they dug deeper and split the data into quartiles. A quartile divides data points into 4 equal parts, or quarters. Here's where the really cool stuff started happening. The data analysts discovered that there was a big difference between the very top and the very bottom quartiles. As it turned out, the teams with the best managers were significantly happier, more productive, and more likely to want to keep working at Google. This confirmed that managers were valued and make a big difference. Therefore, the idea of having only individual contributors was not implemented. But there was still more work to do. Just knowing that great managers create great results doesn't lead to actionable insights. You have to identify what exactly makes a great manager. So the team took 2 additional steps to collect more data. First, they launched an awards program where employees could nominate their favorite managers. For every submission, you had to provide examples or data about what makes that manager great. The second step involved interviewing managers who are graphed on the top and bottom quartiles. This helped the analytics team see the differences between successful and less successful management behaviors. The best behaviors were identified, as were the most common reasons for a manager needing improvement. The final step was sharing these insights and putting a procedure in place for evaluating managers with these qualities in mind. This data-driven decision continues to create an exceptional company culture for my colleagues and me. Thanks, data. Another interesting example comes from the nonprofit sector. Nonprofits are organizations dedicated to advancing a social cause or advocating for a particular effort, such as food security, education, or the arts. In this case, data analysts research how journalists can make a more meaningful impact for the nonprofits they would write about. Because journalists write for newspapers, magazines, and other news outlets, they can help nonprofits reach readers like you and me, who then take action to help nonprofits reach their goals. For instance, say you read about the problem of climate change in an online magazine. If the article is effective, you learn more about the cause and might even be compelled to make greener choices in your day-to-day life, volunteer for a nonprofit, or make a donation. That's an example of the journalist's work bringing about awareness, understanding, and engagement. So, back to the story. The data analysts used a tracker to monitor story topics, clicks, web traffic, comments, shares, and more. Then they evaluated the information to make recommendations for how the journalists could do their jobs even better. In the end, they came up with some great ideas for how nonprofits and journalists can motivate people everywhere to work together and make the world a better place. There's really no end to what you can do as a data analyst. As you progress through this program, you'll discover even more possibilities. Great job following along with the topics in these past few videos. You learned all about analytical skills and the 5 key characteristics of data analysts. You probably even learned that you're a pro at most of these already. Next, you discovered what it means to think analytically and the specific skills data analysts develop to help them do it. You explore tools and processes that enable data analysts to pinpoint a problem and ask the right questions in order to solve it. Finally, some real-world stories helped illustrate why data-driven decision-making is usually more successful than other methods. You're building a wonderful foundation for your career as a data analyst. With every video, your skills will continue to expand and your understanding of key data analytics concepts will only get stronger. Soon, you'll have a chance to test out everything you've learned. This is a really useful opportunity to check your understanding of all the concepts we've discussed. And if you're ever unsure about a question, you can review the videos and readings to find the answer. This is another awesome way to practice collecting data. Keep up the great work. Here's a question for you. When you think about a life cycle, what's the first thing that comes to mind? Now, I'm not a mind reader, but I know whatever you're thinking is right. There's actually no wrong answer because everything has a life cycle. One of the most well-known examples of a life cycle is a butterfly. Butterflies begin as eggs, hatch into caterpillars, and then become a chrysalis. That's where the real magic happens. Data has a life cycle of its own too. In this video, we're going to talk about each of the stages in that life cycle to help you understand the individual phases data goes through. The life cycle of data is plan, capture, manage, analyze, archive, and destroy. Let's start with the first phase, planning. This actually happens well before starting an analysis project. During planning, A business decides what kind of data it needs, how it will be managed throughout its life cycle, who will be responsible for it, and the optimal outcomes. For example, let's say an electricity provider wanted to gain insights into how to save people energy. In the planning phase, they might decide to capture information on how much electricity its customers use each year, what types of buildings are being powered, and what types of devices are being powered inside of them. The electricity company would also decide which team members would be responsible for collecting, storing, and sharing that data. All of this happens during planning, and it helps set up the rest of the project. The next phase is when you capture data. This is where data is collected from a variety of different sources and brought into the organization. With so much data being created every day, the ways to collect it are truly endless. One common method is getting data from outside resources. For example, if you're doing data analysis on weather patterns, you'd probably get data from a publicly available data set like the National Climatic Data Center. Another way to get data is from a company's own documents and files, which are usually stored inside a database. While we've mentioned databases before, we haven't gone into too much detail about what they are. A database is a collection of data stored in a computer system. In the case of our electricity provider, the business would probably measure data usage among its customers within a database that it owns. As a quick note, when you maintain a database of customer information, ensuring data integrity, credibility, and privacy are all important concerns. You'll learn a lot more about that later on. Now that we've captured our data, we move on to the next phase of the data lifecycle, manage. Here we're talking about how we care for our data, how and where it's stored, the tools used to keep it safe and secure, and the actions taken to make sure that it's maintained properly. This phase is very important to data cleansing, which we'll cover later on. Next, it's time to analyze your data. This is where data analysts really shine. In this phase, the data is used to solve problems, make great decisions, and support business goals. For example, one of our electricity company's goals might be to find ways to help customers save energy. Moving on, the data lifecycle now evolves to the archive phase. Archiving means storing data in a place where it's still available but may not be used again. During analysis, analysts handle huge amounts of data. Can you imagine if we had to sort through all of the available data that's out there, even if it was no longer useful and relevant to our work? It makes way more sense to archive it than to keep it around. And finally, the last step of the data lifecycle, the destroy phase. Yes, it sounds sad, but when you destroy data, it won't hurt a bit. So let's get back to our electricity provider example. They would have data stored on multiple hard drives. To destroy it, the company would use a secure data erasure software. If there were any paper files, they would be shredded too. This is important for protecting a company's private information, as well as private data about its customers. And there you have it, the data life cycle. And now that you understand the different phases data goes through during its life cycle, you can better understand how to approach the data analysis process, which we'll talk about soon. Now that you understand all the phases of the data lifecycle, it's time to move on to the phases of data analysis. They sound similar, but are two different things. Data analysis isn't a life cycle. It's the process of analyzing data. Coming up, we'll look at each step of the data analysis process and how it will relate to your work as a data analyst. Even this program is designed to follow these steps. Understanding these connections will help guide your own analysis and your work in this program. You've already learned that this program is modeled after the stages of the data analysis process. This program is split into courses, 6 of which are based upon the steps of data analysis: ask, prepare, process, analyze, share, and act. Okay, let's start with the first step in data analysis, the ask phase. In this phase, we do 2 things. We define the problem to be solved, and we make sure that we fully understand stakeholder expectations. Stakeholders hold a stake in the project. They are people who have invested time and resources into a project and are interested in the outcome. Let's break that down. First, defining a problem means you look at the current state and identify how it's different from the ideal state. Usually, there's an obstacle we need to get rid of or something wrong that needs to be fixed. For instance, a sports arena might want to reduce the time fans spend waiting in the ticket line. The obstacle is figuring out how to get the customers to their seats more quickly. Another important part of the ask phase is understanding stakeholder expectations. The first step here is to determine who the stakeholders are. That may include your manager, an executive sponsor, or your sales partners. There can be lots of stakeholders, but what they all have in common is that they help make decisions, influence actions and strategies, and have specific goals they want to meet. They also care about the project, and that's why it's so important to understand their expectations. For instance, if your manager assigns you a data analysis project related to business risk, it will be smart to confirm whether they want to include all types of risks that could affect the company, or just risks related to weather, such as hurricanes and tornadoes. Communicating with your stakeholders is key in making sure you stay engaged and on track throughout the project. So as a data analyst, developing strong communication strategies is very important. This part of the ask phase helps you keep focused on the problem itself, not just its symptoms. As you learned earlier, the 5 whys are extremely helpful here. In an upcoming course, you'll learn how to ask effective questions and define the problem by working with stakeholders. You'll also cover strategies that can help you share what you discover in a way that keeps people interested. After that, we'll move on to the prepare step of the data analysis process. This is where data analysts collect and store data they'll use for the upcoming analysis process. You'll learn more about the different types of data and how to identify which kinds of data are most useful for solving a particular problem. You'll also discover why it's so important that your data and results are objective and unbiased. In other words, any decisions made from your analysis should always be based on facts and be fair and impartial. Next is the process step. Here, data analysts find and eliminate any errors and inaccuracies that can get in the way of results. This usually means cleaning data, transforming it into more useful format, combining 2 or more data sets to make information more complete, and removing outliers, which are any data points that could skew the information. After that, you'll learn how to check the data you prepared to make sure it's complete and correct. This phase is all about getting the details right, so you'll also fix typos, inconsistencies, or missing and inaccurate data. And to top it off, you'll gain strategies for verifying and sharing your data cleansing with stakeholders. Then it's time to analyze. Analyzing the data you've collected involves using tools to transform and organize that information so that you can draw useful conclusions, make predictions, and drive informed decision making. There are lots of powerful tools data analysts use in their work, and in this course you'll learn about 2 of them: spreadsheets and structured query language, or SQL, which is often pronounced SQL. The next course is based on the share phase. Here, you'll learn how data analysts interpret results and share them with others to help stakeholders make effective, data-driven decisions. In the share phase, visualization is a data analyst's best friend. So this course will highlight why visualization is essential to getting others to understand what your data is telling you. With the right visuals, facts and figures become so much easier to see, and complex concepts become easier to understand. We'll explore different kinds of visuals and some great data visualization tools. You'll also practice your own presentation skills by creating compelling slideshows and learning how to be fully prepared to answer questions. Then we'll take a break from the data analysis process to show you all of the really cool things you can do with the programming language R. You don't need to be familiar with R or programming languages in general. Just know that R is a popular tool for data manipulation, calculation, and visualization. And for our final data analysis phase, we have ACT. This is the exciting moment when the business takes all of the insights you, the data analyst, have provided and puts them to work in order to solve the original business problem. And will be acting on what you've learned throughout this program. This is when you'll prepare for your job search and have the chance to complete a case study project. It's a great opportunity for you to bring together everything you've worked on throughout this course. Plus, adding a case study to your portfolio helps you stand out from the other candidates when you interview for your first data analyst job. Now you know the different steps of the data analysis process and how our course reflects it. You have everything you need to understand how this course works. And my fellow Googlers and I will be here to guide you every step of the way.
Regardless of what type of data analysis you're conducting, the process is generally the same. The example that I'll walk through is that of our employee engagement survey, but you can imagine that this process applies to just about any data analysis that you're going to conduct as an analyst. The first thing you want to do is ask. You want to ask all of the right questions at the beginning of the engagement so that you better understand what your leaders and stakeholders need from this analysis. So the types of questions that I generally ask are around, what is the problem that we're trying to solve? What is the purpose of this analysis? What are we hoping to learn from it? So after you've asked all the right questions and you've wrapped your arms around the scope of the analysis you need to conduct, the next step is to prepare. We need to be thinking about what type of data we need to answer those key questions. This could be anything from quantitative data or qualitative data. It could be cross-sectional or point in time versus longitudinal over a long period of time. We need to be thinking about the type of data we need in order to answer the questions that we've set out to answer based on what we learned when we asked the right questions. We also need to be thinking about how we're going to collect that data, or if we need to collect that data. It may be the case that we need to collect this data brand new, and so we need to think about what type of data we're going to be collecting and how. For our employee engagement survey, we do that via a survey of both quantitative and qualitative questions. But it may actually be the case that for many analyses, the data that you're looking for already exists. Then it's a question of working with those data owners to make sure that you're able to leverage that data and use it responsibly. After you've done all the hard work to collect your data, now you need to process that data. It begins with cleaning. This, to me, is the most fun part of the data analytics process. We can think of it as the initial introduction or the handshake, hello to your data. This is where you get a chance to understand its structure, its quirks, its nuances, and you really get a chance to understand deeply what type of data you're going to be working with and understanding what potential that data has to answer all of your questions. This is such an important part, too, where we're running through all of our quality assurance checks. For example, do we have all of the data that we anticipated we would have? Are we missing data at random, or is it missing in a systematic way such that maybe something went wrong with our data collection effort? If needed, did we code all of our data the right way? Are there any outliers that we need to treat differently? This is the part where you spend a lot of time really digging deeply into the structure and nuance of the data to make sure that you're able to analyze it appropriately and responsibly. After cleaning our data and running all of our quality assurance checks, now is the point where we analyze our data, making sure to do so in as objective and unbiased a way as possible. To do this, the first thing we do is run through a series of analyses that we've already planned ahead of time based on the questions that we know we want to answer from the very, very beginning of the process. One thing that's probably the hardest about this particular process, the hardest thing about analyzing data, is that we as analysts are trained to look for patterns. And over time, as we become better and better at our jobs, what we'll often find is that we can start to intuit what we might see in the data. We might have a sneaking suspicion as to what the data are going to tell us. And this is the point where we have to take a step back and let the data speak for itself. As data analysts, we are storytellers, but we also have to keep in mind that it is not our story to tell. That story belongs to the data, and it is our job as analysts to amplify and tell that story in as unbiased and objective a way as possible. The next step is to share all of the data and insights that you've generated from your analyses. Now, typically for our employee engagement survey, we start by sharing the high-level findings with our executive team. We want them to have a landscape view of how the organization is feeling, and we want to make sure that there aren't any surprises as they dig deeper and deeper into the data to understand how teams are feeling and how individual employees are feeling. All of this work, from asking the right questions to collecting your data to analyzing and sharing, doesn't mean much of anything if we aren't taking action on what we've just learned. This, to me, is the most critical part, especially of our employee engagement survey. I like to say that the survey is actually the easy part, and acting on the results is really where the real work begins. This is where we use all of those data-driven insights to decide what types of interventions we want to introduce, not only at the organizational level, but also at the team level as well. So we might find, for example, that the organization is working on a series of interventions to help improve part of the employee experience, whereas individual teams have additional roles and responsibilities to play to either bolster some of those efforts or to introduce new ones to sort of better meet their team where their strengths and opportunity areas are. The data analysis process is rigorous, but it is lengthy, and I can completely appreciate that we as data analysts get so excited about just diving right into the data and doing what we do best. The challenge is that if we don't work through the process in its entirety, if we try to skip steps, we're not going to be able to elicit the insights that we're looking for. I absolutely love my job. I have such a deep appreciation for data and what it can do and what type of insight we can derive from it.
Welcome back. In the next few videos, you'll continue to explore the data analytics tools we discussed earlier, and you'll get the chance to see them in action a little bit. This will give you a clearer picture of how to use these tools. The rest of the program will build on from what you learned here. We'll start with a closer look at spreadsheets. We'll break spreadsheets down to their basics to better understand a few of their features and functions. You'll also learn how you might want to use them in your work as a data analyst. For example, how do you sort your data to make it easier to use? We'll find out. Next, we'll see SQL in action. Data analysts use SQL in their work all the time, like when they need a large amount of data in seconds to help answer a quick business question. Chances are you're not familiar with SQL. That's okay. You'll learn how using SQL is just like ordering food at a super speedy restaurant. Your SQL query might not be as delicious, but you won't have to wait long to get your order. Speaking of food, what better topic than dessert? You can think of data visualization as the dessert to the meal of data analytics. It's served at the end of your analysis after you've done what you need to get the right data for a question or task. We've already seen that visualizations come in a lot of forms, like graphs or charts. And just like dessert, they're a treat to look at. You'll learn more about these visual representations and see other examples of how they might look. Then, you'll get to talk about visualizations with other future data analysts just like yourself. We'll wrap things up with an assessment, but you'll have time to review what you've learned before then. Okay, let's keep going. By the way, is anyone else hungry now? Wow, your data analysis toolbox is getting full. Learning about both spreadsheets and SQL will get you far in the world of data analysis. There's more to learn, of course, and lots more tools you'll be able to use, but your future is looking bright. And it's about to look even brighter because we're here to talk more about data visualization. I'll tell you a little more about the role of data visualization tools in data analytics and give you a chance to see those tools in action later in this video. You might remember that data visualization is the graphical representation of information. For tons of data analysts, it's the most exciting part of their job because they get to see their hard work pay off with something interesting. Not to mention that data visualization is beautiful and useful. I was floored when I got to Google and started to get a quarterly data report in my email. It had a big slide deck where people contributed their visualizations. It was definitely a source of light as I started to build my own visualizations. If you're not impressed by my story, let me tell you about Florence Nightingale. Does that name ring a bell? She's responsible for much of the philosophy of modern nursing. And believe it or not, she was also a data analyst. During the Crimean War in the 1850s, thousands of soldiers were dying every day. Nightingale wanted to find a way to reduce the number of deaths. After examining the data, she found that the majority of soldiers were dying from preventable conditions. To convince hospital administrators that they needed to focus on these conditions, she created a chart showing the number of deaths over several months. The much larger blue sections in the visualization represent the preventable deaths. Her work directly led to major changes in patient care. And she did all of this over 150 years ago without a computer. One of the main reasons Nightingale created this visualization was to make the data easier to digest for her audience. She felt she'd be more successful convincing the stakeholders using visuals instead of just words and numbers. She was right. Tables filled with data, while necessary for analysis, just aren't able to show trends and patterns as quickly and clearly as visualizations can. Imagine you receive an assignment that needs to be completed the same day. You gather the data you need in a table. Could you explain your findings using the table? Yes, you probably could. But a better idea would be to use a visualization like this bar graph. Something like this makes it much easier for you to explain quickly. And you've got the benefit of a cool graphic to back up your analysis. As a data analyst, you'll want to create visualizations that make the data easy to understand and interesting to look at. So show it off. Stakeholders may not have much time to devote to the data. Your job will be to make their time worthwhile. Let's go back to that data table we created earlier in the course. If you created your own for practice, you can open it up now or try this out later. Here's the data we added before. Let's create a visualization of the data by inserting a chart, a bar graph. Boom. You can see that the spreadsheet visualized the data from our table in a way that made the most sense. It created a bar graph or column chart to compare the ages of each person by name. But you might have figured that out already. That's the beauty of visualization. It shows data analysis quickly and clearly. We can use Chart Editor to adjust the chart. Different spreadsheet programs might have different ways to do this, but they all have visualization functions and ways to edit those visualizations. All right, for now, let's just look at the suggested charts. We can make the bars go horizontally using a bar chart. That looks great. So let's close the chart editor. There are lots of options to look at, but we'll keep it basic for now. Feel free to try other visualizations if you practice later. Now we can adjust our chart to make our whole spreadsheet look clean and professional. Excellent. I hope you learned to love data visualization as much as I do. Maybe you'll become a data visualization pioneer just like Florence Nightingale. As a budding data analyst, you've started to fill your utility belt with valuable tools that you'll use throughout the rest of the program. Having spreadsheets, SQL, and data visualization know-how will help make you an ace data detective. You'll be able to use these tools throughout the data analytics process as you move forward. Coming up next, you'll complete a few activities to wrap up this part of the program. You'll also complete an assessment to check your understanding of all that you learn. This is a great opportunity to think about some of the areas that you'll continue to explore in this course and in your career. As always, feel free to review the videos and readings to help remind you of certain topics and ideas, even if you already feel prepared. You're just a few steps away from the next course. That's great progress. Keep it up.
My name is Lila Jones, and I am a part of our cloud team. I get a chance to lead a team of amazing individuals that are focused on helping customers get to the cloud. Data visualizations. That's a long word, and that can also make your eyes glaze over. But I wonder if when you were little and you were with your parents, maybe they had a bedtime routine, or maybe you have children, you're doing a bedtime routine with them, you very rarely are going to come to those children with a bunch of facts and figures before they go to bed. But I bet you probably are telling them a story. You're showing them pictures. I know I always loved comic books. Pictures tell a story. Data visualizations are pictures. They are a wonderful way to take very basic ideas around data and data points and make them come alive. You can do all different types of combinations of visualizations, but the ones that are interactive, wow, those are huge. Can you imagine being an executive in an organization and trying to figure out, wow, should we open up another site in Bangkok? Does that make sense? And us being able to walk in and saying, here's why it makes sense, and having great data visualizations to support all of our points of view makes it a no-brainer. Interestingly enough, I do recall the first time I came across a super amazing visualization. It was in my personal life. I switched my budgeting software from one provider to another. And the provider that I switched to was really focused on every dollar has a job and making sure you're budgeting every single dollar. They gave visualizations that changed depending on what input you would add to it. And it really just changed my entire perspective, the entire thing. So having the data is like having the answer sheet for a test. It really just lets you know that you're going to make good decisions because it's backed up by data.
Hey, great to have you back. Now it's time to get down to business. We're going to start talking about practical ways businesses are using data and the opportunities that it can create for you. So far, you've learned a lot of practical data analysis skills. With these next couple of videos, we're going to switch gears a little and talk about why you're learning these skills. Hopefully this will give you more perspective into what kinds of opportunities are out there for you. Coming up, we're going to talk more about the kinds of roles data analysts play in different industries, the tasks that these roles require, and the importance of fairness and avoiding bias in analyzing data for business tasks. We'll also talk about opportunities you can tap into and how this program factors into your future success in the data analyst role. So with all that in mind, let's get started. Previously, we learned about what a data analyst does and why that work is so valuable. Now, let's look at where data analysts actually do their work. You'll learn much more about the industries you could work in as a data analyst and how companies in these fields are already using data analytics to do some really cool things. There are so many businesses out there that have a big need for the skills you're learning right now. Across industries like technology, marketing, finance, healthcare, and so many more, real companies are already using data analytics to stay ahead of the curve. And the more they use data in their business, the more they understand just how important data analysts like you are to their success. Let's look at a real-life example of a brand you'll probably recognize, Coca-Cola. Data is changing the way Coca-Cola approaches its marketing strategies. Coca-Cola uses data gathered from consumer feedback to create advertising that speaks directly to different audiences with different interests. How does this work? You know those high-tech Coca-Cola vending machines you see at movie theaters sometimes? It's always fun getting to make your own flavors. Well, those machines have built-in artificial intelligence and data analysis tools. This helps Coca-Cola see all the different kinds of flavor combinations people are coming up with, which they can then use as inspiration for new products. How cool is that? Ever wonder how Google gives you the right answer to any question in just seconds? That's powered by data too. We use all kinds of data to determine a website's reliability and accuracy to make sure you get the most useful results for any search you make. But it isn't just big companies like Coca-Cola and Google that use data. Small businesses everywhere are also starting to take advantage of data-driven insights to improve their operations and make better decisions. Small businesses can use data to do all kinds of things. They might use data analytics to better understand their customers' buying habits, create more effective social media messaging, or, in the case of one city zoo and aquarium, predict the number of daily visitors based on local climate data. City Zoo and Aquarium realized that on rainy days, they were seeing huge drop-offs in attendance, but they had no way to accurately predict when those rainy days would hit. This made staffing a real challenge. Some days they found themselves overstaffed, other days they were unprepared for the rush of visitors. To deal with this, data analysts took years of weather records from the zoo and used that data to accurately predict future weather patterns. This made it easy for the zoo to know how much staff they needed when. Because the zoo could predict and manage their staffing needs more accurately, they were able to provide a better experience for visitors and dedicate more resources to creating a better experience for the animals too. We see a similar thing in the healthcare industry. There, data analysts look at clinic attendance data to help hospitals and doctors' offices predict when rush hours will hit so they can be ready for it. Your local city hospital is a great example. Let's say they've been getting complaints about long wait times, sometimes an hour or more, which made it hard for some patients to get the care they needed. So data analysts use data about the hospital's daily foot traffic to help them make more informed decisions about how many doctors they need on staff at any given time. This helped reduce wait times, improve their patients' experience, and make better use of the healthcare workers' time too. Like I said, there are many ways that companies in different industries put data to use, but they can only do that if they have data analysts they can rely on. So you might be wondering how you fit into the equation. Well, you've got plenty of options, but you don't have to decide what industry you want to work in right away. There will be plenty of time to think about that as you make your way through this program. By the time you finish this program, you'll have the core skills that will make you valuable in any industry that makes data-driven decisions, which, as it turns out, is most industries, even zoos. Coming up, we'll check out the business task where data can be helpful, and we'll explore even more how data analysts are empowering businesses through data. I'll see you then.
Hi, I'm Joey, and I work as an analytics program manager within RUSE. Now, RUSE stands for Real Estate and Workplace Services, and my job is to bring data and analytics into the decision-making here, especially with regards to creating a safe and fun work environment. My journey into analytics was a bit different in that I had no plan or really didn't see myself being where I am now. Now, luckily, I started in a rotational program called the HRA program within people operations, which afforded me the ability to play 3 different roles, essentially. I was in a generalist capacity, in a specialist role, and as an analyst. And I really found a love and a passion in the analytical work. I started on the business intelligence team, whose job was to provide SQL-based reporting back to the business. I realized that analytics is the right career path for me when I found myself enjoying coming to work and getting my work done. And I think I can connect that to 2 passions of mine. The first is problem solving. I love taking a complex problem, a mystery, a riddle, and being able to find the answers and come up with the solution. And then the second thing is being able to work with people and help people. In analytics, I feel like the key to success is being able to blend the personal side with the technical side. At the beginning of my career, I focused a little more on the technical pieces, and I wanted to make sure I had the right technical knowledge to be able to answer questions. But what I found is over time, I needed to grow that other side just as much. And I think that my career has allowed me those opportunities to kind of work each of those muscles, the human interaction part and the technical part, to make sure that they're both growing at the end of the day.
As a data analyst, you'll be tackling business tasks that help companies use data. Coming up, we'll talk more about what a business task actually is and some examples of what they might look like in real data analyst jobs. Let's take a second to think back on the real examples of businesses using data analytics in their operation we've seen before. You might have noticed a common theme across every example. They all have issues to explore, questions to answer, or problems to solve. It's easy for these things to get mixed up, so here's a way to keep them straight when we talk about them in data analytics. An issue is a topic or subject to investigate. A question is designed to discover information, and a problem is an obstacle or complication that needs to be worked out. Coca-Cola had a question about new products. Data analysis gave them insights into new flavors customers already like. The city zoo and aquarium had a problem with staffing. Data helped them figure out the best staffing strategy. These questions and problems become the foundation for all kinds of business tasks that you'll help solve as a data analyst. A business task is the question or problem data analysis answers for a business. This is where you'll focus a lot of your efforts in the work you'll do for future employers. Let's stick with our zoo example and see if we can imagine what a business task for a zoo might look like. We know the problem. Unpredictable weather was making it hard for the zoo to anticipate staffing needs. So maybe the business task could be something like analyze weather data from the last decade to identify predictable patterns. The data analyst could then plan out the best way to gather, analyze, and present the data needed to solve this task and meet the zoo's goals. Then, using data, the zoo would be able to make informed decisions about their daily staffing. So we talked a little about data-driven decision-making in previous videos. But just in case you need a refresher, here it is. Data-driven decision-making is when facts that have been discovered through data analysis are used to guide business strategy. The simplest way to think about decision-making is that it's a choice between consequences, good, bad, or a combination of both. In our zoo example, the zoo had the data they needed to make an informed decision that solved their problem. But what if they had made this decision without data? Let's say they just relied on observation and memory to track the weather and make staffing schedules. Well, we already know that wouldn't have solved their problem long term. Data analytics gave them the information they needed to find the best possible solution to their problem. That's the power of data. Observation and intuition are powerful tools in decision making, but they can only take us so far. When we make decisions based on just observation and gut feelings, we're only seeing part of the picture. Data helps us see the whole thing. With data, we have a complete picture of the problem and its causes, which lets us find new and surprising solutions we never would have been able to see before. Data analytics helps businesses make better decisions, and it all starts with a business task and the question it's trying to answer. With the skills you'll learn throughout this program, you'll be able to ask the right questions, plan out the best way to gather and analyze data, and then present it visually to arm your team so they can make an informed, data-driven decision. And that makes you critical to the success of any business you work for. Data is a powerful tool, and with great power comes, well, you know the rest. And you're doing a super job taking in all of this information. Up next, we'll talk about your responsibility as a data analyst to make sure you're gathering, analyzing, and presenting data in a way that's fair to the people being represented by that data.
Hi, my name is Rachel, and I'm the Business Systems and Analytics Lead at Verily. There are a lot of different types of problems that a data analyst can solve. I've been lucky enough over my career to have seen a lot of them and to take in a lot of very different types of data and help turn that into meaningful answers. I think one of the most important things to remember about data analytics is that data is data. I'm a finance data analyst. And so my role at Verily is to take all of our financial information, all of the information of the money we're spending and the money we're making, and turn that into reports and insights so that our business leads can understand what we're doing. One of the most important things I've done at Verily recently was help create what's called a profit and loss statement for each of our business units. And that means that in real time, our teams can see what their budget is and how they're spending against that budget. And what that does is that helps our teams keep to that budget by either increasing their revenue streams so that they have more money to play with, or pulling back their spending so that they can keep themselves within that budget. And all of that really helps keep us on track as a company and making sure that we're hitting our goals. I've found that data acts like a living and breathing thing. When you have a ton of data points, it can be overwhelming when you first sit down to make sense of it. You have tons of columns, tons of records, tons of different types of data, and finding a way to make sense of that is really hard. And that's where the expertise of a data analyst comes in. It has been some of the most frustrating moments of my career, but also some of the most rewarding work I've ever done when it finally comes together. The best advice I have for any data analyst starting out is keep at it. If the angle you're taking doesn't work, try to find another one. Try to come at it in a different way. Try to ask a different question. Eventually, the data will yield, and you'll get the insights you're looking for.
So far, we've covered the different roles data analysts play in business environments and the kinds of tasks that come with those roles. But data analysts have another important responsibility: making sure that their analysis are fair. Now, I know what you're probably thinking. Data is based on collected facts. How can it be unfair? Well, that's a good question. So let's learn what fairness means when we talk about data analysis and why it's important for you as an analyst to keep in mind. Fairness means ensuring that your analysis doesn't create or reinforce bias. In other words, as a data analyst, you want to help create systems that are fair and inclusive to everyone. Sound simple enough? Well, here's the tough part about fairness in data analytics. There isn't one standard definition of it. But hopefully the way we've just described it can give you one way to think about fairness for right now. But it's about to get a bit trickier. Sometimes conclusions based on data can be true and unfair. What can you do then? Well, let's find out with an example. Let's say we have a company that's notorious for being kind of a boys' club. There isn't much representation of other genders. This company wants to see which employees are doing well, so they start gathering data on employee performance and their own company culture. The data shows that men are the only people succeeding at this company. Their conclusion? That they should hire more men. After all, they're doing really well here, right? But that's not a fair conclusion for a couple of reasons. First, it doesn't even consider all of the available data on company culture, so it paints an incomplete picture. Second, it doesn't think about the other surrounding factors that impact the data. Or in other words, the conclusion doesn't consider the difficulties that people of different gender identities have trying to navigate a toxic work environment. If the company only looks at this conclusion, they won't acknowledge and address how harmful their culture is, and they won't understand why certain people are set up to fail within it. That's why it's important to keep fairness in mind when analyzing data. The conclusion that only men are succeeding at this company is true, but it ignores other systematic factors that are contributing to this problem. But don't worry, there's a way to make a fair conclusion here. An ethical data analyst could look at the data gathered and conclude that the company culture is preventing some employees from succeeding, and the company needs to address those problems to boost performance. See how this conclusion paints a much more complete and fair picture. It recognizes the fact that some people aren't doing as well in this company and factors in why that could be, instead of discriminating against a huge number of applicants in the future. As a data analyst, it's your responsibility to make sure your analysis is fair and factors in the complicated social context that could create bias in your conclusions. It's important to think about fairness from the moment you start collecting data for a business task to the time you present your conclusions to your stakeholders. We'll learn more about bias in the data analysis process later on in another course. For now, let's check out an example of a data analysis that does a good job of considering fairness in its conclusion. A team of Harvard data scientists were developing a mobile platform to track patients at risk of cardiovascular disease in an area of the United States called the stroke belt. It's important to call out that there were a variety of reasons people living in this area might be more at risk. With that in mind, these data scientists recognized that fairness needed to be a priority for this project, so they built fairness into their models. The team took several fairness measures to make sure they were being as fair as possible when examining sensitive and potentially biased data. First, they teamed analysts with social scientists who could provide insights on human bias and the social context that created them. They also collected self-reported data in a separate system to avoid the potential for racial bias, which might skew the results of their study and unfairly represent patients. And to make sure their sample population was representative, they oversampled non-dominant groups to ensure their model was including them. It's clear that the team made fairness a top priority every step of the way. This helped them collect data and create conclusions that didn't negatively impact the communities they were studying. Hopefully these examples have given you a better idea of what fairness means in data analysis. But we're going to keep building on our understanding of fairness throughout this program. And you'll get to practice with some activities.
Hi, I'm Alex. I'm a research scientist at Google. My team is called the Ethical AI team, and we're a group of folks that really are concerned not only about how AI and the technology operates, but how it interacts with society and how it might help or harm marginalized communities. So when we talk about data ethics, we think about, what is the good and right way of using data? What are going to be ways that are going to be uses of data that are going to be beneficial to people? When it comes to data ethics, it's not just about minimizing harm, but it's actually this concept of beneficence. How do we actually improve the lives of people by using data? When we think about data ethics, we're thinking about who's collecting the data, why are they collecting it, how are they collecting it, and for what purpose? Because of the way that organizations have imperatives to make money or to report to somebody or provide some kind of analysis, we also have to keep strongly in mind how this is actually going to benefit people at the end of the day. Are the people represented in this data going to be benefited by this? And I think that's the thing you never want to lose sight of as a data scientist or a data analyst. I think aspiring data analysts need to keep in mind that a lot of the data that you're going to encounter is data that comes from people. So at the end of the day, data are people. And you want to have a responsibility to those people that are represented in those data. Second is thinking about how to keep aspects of their data protected and private. We don't want to go through our practice thinking about data instances as something we could just throw on the web. No, there needs to be considerations about how to keep that information and likenesses like their images or their voices or their text. How do we keep that private? We also need to think about how we can have mechanisms of giving users and giving consumers more control over their data. It's not going to be sufficient just to say we collect all this data and trust us with all these data, but we need to ensure that there's actionable ways in which people can consent to giving those data and ways that they can ask for it to be revoked or removed. So data is growing, and at the same time, we need to empower people to have control over their own data. The future is that data is always growing. We haven't seen any kind of evidence that data is actually shrinking. And with the knowledge that data is growing, these issues become more and more peaked and more important to think about.
By now, we know that there are all kinds of jobs in different industries available for data analysts. But now it's time to think about something just as important. How can you tell if a job is a good fit for you and your career goals? Tough one, right? Don't worry, that's exactly what we'll cover in this video. There's a lot of important factors to think about when searching for your dream job. Let's talk about some of the most common factors first. Industry, tools, location, travel, and culture. Data is already being used by countless industries in all kinds of different ways: tech, marketing, finance, healthcare. The list goes on. But one thing that's important to keep in mind: every industry has specific data needs that have to be addressed differently by their data analysts. The same revenue data can be used in 3 different ways by data analysts in 3 different industries: financial services, telecom, and tech. For example, a finance analyst at a bank pulls public revenue data of telecom company X to create a forecast that predicts where revenues will be in the future to recommend a stock price. The business analyst at telecom company X uses that same data to advise the sales team. Then a data analyst at the company who created a customer management tool for telecom company X will use that revenue data to determine how efficiently their software is performing. Finance, telecom, and tech all use data differently, so they need analysts who have different skills. It all comes down to what the needs of the industry are. Those needs will determine what kind of task you'll be given, the questions you'll be answering, and even how you'll approach job searching. If you're just starting out, a great way to guide your search is to think first about what you're interested in. Does helping people get healthier sound meaningful to you? Maybe you want to focus on using data to improve hospital admissions. What about helping people save for a happy retirement? You might want a job that uses data to determine risk factors in financial investments. Or maybe you're interested in helping journalism grow in your city. A job using data to help find your local news website find more subscribers could be the perfect role for you. The key is to think about your interest early in your job search. That'll lead you in the right direction, and it'll help you in interviews too. Potential employers will want to know why you're interested in their company and how you can address their needs. So if you can speak about your motivation to work in data analytics during interviews, you'll make yourself stand out in a great way. You'll have options when it comes to where you work and who you work for. But remember, you want to enjoy what you do. So it's a good idea to think about how you want to use your skills, then search for jobs that allow you to do that. Next on the list of things to think about, location and travel. When you start your job search, you need to make some decisions about where you want to live. So it helps to ask yourself some questions. Does your preferred industry have opportunities in your area? Are you trying to stay local, or would you be happy relocating? How long are you willing to commute to work every day? Will you drive to work, walk, take public transport? Is that possible year-round? How do you feel about working remotely? Does working from home excite you or bore you? And of course, you'll want to consider cost of living and whether or not you want the convenience of city living or a quiet suburban home. And it's not just about where you'll be based. Some jobs may ask you to travel, which could be an exciting chance to see the world or a deal breaker. It's all about what you want out of this job. So start asking yourself some of these questions. Figuring out the answers can help you narrow down your search even further, so you're only looking at jobs you'd actually accept. Once you've answered enough questions, you'll be able to identify some specific companies that fit your needs. At this point, it's a good time to think about your values and what kind of company culture is a good fit for you. Ready? Here come some more questions. Do you work best in a team or by yourself? Do you like to have a set routine, or do you enjoy taking a new project and trying new things? Do your values match the company's values? You'll want to pay attention to these things during your job search and interview process so you can be sure you fully invested in the company you work for. That's the best way to start building an exciting and fulfilling career. This program will help you learn the core skills for data analytics in any setting. It's up to you where you want to take them. Whether that means starting in a completely new industry or moving into an analyst position in an industry you already have experience in. And hopefully what we've covered here has helped you get on track for your future job search. After this, you'll have a few activities to do, and then you'll be able to move on to the next part of this course. We learned a lot so far, like what kinds of opportunities are out there for data analysts in different industries, how data analysts help businesses make better decisions, the importance of fairness in data analytics, and the potential questions you can start asking yourself before your future job search. And you can always look back at these lessons if you want to review. In an upcoming course, we'll look at the skills all successful data analysts have, and you'll learn how you can start practicing them too. But before that, you'll have an assessment. Good luck, and I'll see you later.
My name is Sama Moid, and I'm a recruiter here at Google for the large customer sales team. Basically, I hire talent for the sales team here. Even within the sales recruiting space, I recruit specifically for the analytical lead roles here at Google. I want the candidate to be as comfortable as possible. As a recruiter, I'm also their advocate. If they're a good fit for the team, I'd like to present them in the best light. As a recruiter, some advice I would give for a data analyst that's just starting to look for a job: think about a time where you've used data to solve a problem, whether it's in your professional or personal projects. Another tip I would say for a data analyst that's just looking for a new job is to increase your professional network. There are many ways to increase your professional network. One of them is to increase your online footprint, reach out to other analysts on LinkedIn, join local meetups with other data scientists. Sometimes when we're looking for a unique skill set, recruiters are going on websites like LinkedIn and GitHub and trying to find that talent themselves. It's really important to have your LinkedIn updated along with websites like GitHub, where you can showcase a lot of the data analyst projects you've done. Another tip I would say for an in-person interview is to prepare questions for the interviewer. Make sure they're not broad questions. They should be questions that will help you understand the team and the job better. If you're given a case study in an interview, you should expect to be given a business problem along with a sample data set. Then you'd be asked to take that sample data set, analyze it, and come up with a solution. One of the things you can do to help prepare yourself for this is to ensure you are analyzing the data and coming up with a solution that relates back to that data. Sometimes there is no right answer, and a lot of times interviewers are looking to see your thought process and the way you get to your solution. I highly encourage that if you find a role that you're interested in, not only apply to it, but go the next step. Look for the recruiter, look for the hiring manager online, see if you can reach out to them and set up a coffee chat, or send them your resume directly. Online applications could be a really big black hole where you never hear back from the recruiter or the team. When you reach out directly to a hiring manager or recruiter, it really shows your eagerness for the role and your interest for the role. Even if sometimes you don't get a response from reaching out, you never know. You try multiple different times, and that one time you get a response back from a recruiter or hiring manager could be the time you get the job that you really wanted.
We're at the end of this course, which means it's time to show off what you've learned. We've covered the different kinds of industries using data to drive decisions and how you can help them, how to promote fairness in your data work, and opportunities that are out there in the world of data analytics. I know you've got this, and once you finish the course challenge, I'll be right here to introduce you to the next course.